Okay, so let's continue with our attempt to approach signal processing. And we start this discussing about functions because we are trying to build an intuition. Since this topic, it requires this type of intuition. And alongside, we are plotting these functions using the Octave environment. So we are sketching these functions by hand and discussing concepts like if the function is symmetrically, if we can mirror this function, uh, and even we already has introduced the concept of limit. And on the last video, we were discussing about this function, square root of x. And right here, actually, I commit a mistake. As the function, as we are making x approach to infinite, and the function it assumes this infinite value, so actually it is diverging, not converging. So the function is diverging because it's assuming this infinite value. It never assume as x approach to infinite, never assume a real value. But we can make also x approach to a real value. We can make, for example, x approach to 4, and as x approach to 4, so the function it tends to 2. So square root of 4, which is equal 2. And right here we got the proof. If we make x approach to 4, so the function will assume this real value up to, and if we make the function approach to x approach to infinite, so the function it will grow increase to infinite. Right here, infinite, and it will grow increase to infinite. Okay, and one video before this one, where we introduced this concept of limit, was with this function 1 over x. And if we take the limit of this function as approach to infinite, so the limit of 1 over x as x approach to infinite is equal 0. So we can study this function right here, and we were naming variables and passing this to these variables the limit of the x-axis, and instead of doing this we can already draw the x-axis. So let's pass to this variable x, which is the x-axis, the function line space, and let's pass as argument the ranges of this x-axis, the maximum and the minimum and the max value, and also the number of points that this axis will be drawn. And now let's build the function 1 over x. And now let's plot the function. And as you can see right here, so follow the pointer, the mouse pointer, uh, as we are making the x approach to infinite. So on the infinite, it will touches the axis in 0. So actually, this function uh, converges to 0. So it is converging, it converge to this real value 0. And we can see this right here. On infinite, it touches 0. And let's see if we pass a range more greater than 100, like 1000. And as you can see, is converging in 1000, even before right here 400, it already touching the 0 right here too. Okay, so let's continue with our content, and now we will discuss about a continuous function. So let's see this example, a continuous function. So f of x equal k, and let's assume k as 2, and for any value that we pass for x, the function will always be 2 because it is continuous. So for any value of x, the function will be the same. And its graphical is very simple. -1 for -1, for -2, for 1, for 2, and it can go even to infinite. And the function will always be equal to and now let's build a algorithm to this function right here in Octave on the Octave environment. So is a constant, right? So right here 2, and actually of course, we can attribute to the k constant any value, any real value that we want. And let's see. Okay, it takes a time, it's processing, and that is why I changed the argument to 100 instead of 1000 because it takes a time to process. And there we go. A continuous function. And what else we can add to this discussion? We can take the limit of this function. We can do um, the limit of the of f of x, which is equal to, and we can make, let's do formally, as x approaches to infinite, so this is equal to, even if x is approach to zero to infinite, it tends to 2 value because it's a constant. So always is equal k, which is a constant. And I don't know, we are discussing about how we can adapt such a problems to a real world problem. So let's say in finances, we got a fixed incoming, and now instead again of facing this as f of x, we can face as f of t. So this fixed incoming, so we can adapt to a real world problem. So let's say we got a fixed incoming, sorry, it's fixed income, and at some point this fixed income, um, it is discontinued at any point right here. So let's say in some point this incoming is discontinued. So we wanted to know what happens at this point. And right here, let's say at this point of the time, what happens to this fixed incoming? Just an idea. I don't know. We need to work this problem. And right here we are just covering these basic functions. But again, we can also discuss how we can adapt such a function and try to apply in a real world problem. Now let's see another example. Uh, Now let's say we got a function like that, and the function will assume this negative value -1 if x is greater or equal to 0, and it will assume this positive 1 if x is less than 0 or is positive 1 is 1 if x is greater than 0, sorry, and is -1 if x is less than 0. Okay, so right here, the construction is basically based on its graphic. So we have to do this graphical analysis is visually 0, 1, 2, and it can even go to the infinite, and -1, -2, so right here is x and f of x. So let's see, this side right here is the values which is greater or equal to 0, and this side is the values which is less than 0. And if the function it got values greater or equal to 0, so the function it will be 1 positive, and right here is -1. So right here we got 1, and if the function it assume, sorry, if x is less than 0, very sorry, so if x assume values less than 0, so the function it will assume the value of -1. So let's see how we can build this in Octave, the algorithm for this function. So let's build a function and name it as y. So y is equal f of x. So actually we are defining a function. So define the function f of x, and now the conditions: if x is greater or equal to 0, so it will assume, so now y is equal 1, so the function it will assume the positive one, else the function it will assume the negative one value. Now we end both of the conditions. Now we build our x-axis with the ranges. So we can use t minus 2 in the step of the function, and to 2, and now on the function we need to use the function array_fun, and now we need to use this operator as argument the function. So right here we are using the function array_fun and passing to this function the argument the function. So to pass this function y, which is f of x, as argument right here, we need to use this operator and passing x, the axis, as argument as well. This is the algorithm part. Now the graphic part, because we wanted to plot, so figure, and we ask to plot the function. Let's try. And nothing happens. We ask to plot. Let's see what is going on, what is wrong on this algorithm, on this code. Let's try different. So this part right here, it goes first, and this. Okay, let's try now. This step of the function minus 2, and nothing happens. Let's see now. It didn't work. Okay, let's keep trying. Let me try now this way. So first, attributing the x, the ranges of the x. So this is ranges. x range. We build a function asking to plot, and it will plot this function right here with these conditions. Let's clean the octave memory. So clear all. Okay, so let's try something different. Instead of use this way, let's build a function different. Like, let me see. Let's start from the beginning. Instead of use this, let's say that is a function, and now we need to use this operator. And between parentheses the x, because the function of x. Now the conditions. X, it needs to be equal, greater or equal to 0, and this will be for when x it is greater or equal to 0. The function assumes the one value, and also when x is less than 0, the function it will assume the negative -1 value. And now y array fun f and x argument. Now plotting figure and plot x and y right here. Forgot to put this between parentheses. Okay, let's try. Okay, so we got -1 for values less than 0 and 1 for values greater or equal to 0. We can use this resource like a line width and so let's see. Let's clear the octave memory. Let's try again. Right here is D. Oh. Better. And that's it. Well, takes a while till we got this result, but finally we got. And again, as you could see, I'm using the Lewis Hamilton Guitar Easy to do this introduction to signal processing with you. I'm using this literature. It's a very nice book. I'm using in the Portuguese language. And I think for today is all. So again, let me just pass see you the literature that we are using is the Lewis Hamilton guitarism. I think is that author writes. So this is the book that we are covering. Just to do this, to build this intuition, this first approach, and we are almost getting close to trigonometric functions, maybe one or two videos closer. And that's it. So I hope you like it. Thank you for watching. Thank you for following. And see you in the next video. Thank you.